All right, here we go, Module 3. So we're doing 3.1, representing proportional relationships. So proportional relationships are relationships between two quantities, remember any quantities, in which the ratio, that's the comparison, of one quantity to the other quantity is constant or equal. So constant and equal, same thing, right? It's the same thing over and over and over again. So remember that from our Explore activity, all of our ratios became 3 or 3 over 1. And that was our constant, and then also that's what made them proportional. So it's the same thing over and over and over again. So the constant of proportionality is that a proportional relationship can be described by an equation of the form y equals kx, where k is that constant. So again, from our Explore activity, our constant would have been 3. And so if we wrote an equation for our Explore activity, it would have been y equals 3x. And if you remember from the activity, this was our leagues, and this was our miles. Now, see, even I was having to remember. Right, we took our leagues and we times it by 3, and it gave us the miles. All right, so let's look at our first example of broken it down into steps for us. So it says Megan earns $12 an hour at her part-time job. She shows the relationship between the amount she earned and the number of hours she worked in a says show that the relationship between the amount she earned and the number of hours she worked is a proportional relationship. Then write an equation for the relationship. So they gave us a table. It says make a table if you need to. Like our activity, we finished the table. And so it shows us that in an hour she makes $12, 2 hours she makes $24, 4 hours she makes $48, and then 8 hours she makes $96. So when we have a table, the first one is always considered our x, and the second one is always considered our y. Okay, so anytime you have a table, the first one's always x and the second one's always y. So to prove that it's a proportional relationship, we have to set up ratios. We're going to do the amount earned over the number of hours. Now, the ratio will always be our y over our x. We're always going to compare the y's to the x's, okay? So when we check that it's a proportional relationship, we have to do every single one and prove that they all equal the same thing. So I'm going to go 12 over 1, which equals 12. Then we'll do 24 over 2, which equals 12. And then we would do 48 over 4, which equals 12. And then our last one is 96 over 8. Now you can look at your multiplication chart and see that 96 divided by 8 would be 12. But also in this bubble up here, it even says that 8 times 12 equals 96. So since we get 12, 12, 12, and 12, we can say that our constant is 12. So remember from that first slide that the K stands for our constant, and so we would say it's 12. Remember, this is our constant. So now that we have our constant, we can write our equation. So it's y equals kx, and then so we would write y equals 12x. And there's your equation. So the reason we leave y and x blank is so that we can figure it out for no matter which number of hours she works, or if we know how much she earned, we can then figure out how many hours she worked. So it's so that it's generalized and not specific to the number she gave us. We can find it for anything, any amount of hours or any amount she earns now. So we can also use a graph to find out the information. We don't have to make a table. We can always use a graph too. So this is a graph shows the relationship between the weight of an object on the moon and its weight on Earth. Write an equation for the relationship. So they gave us a graph and then they gave us some points. So you can see they matched them up. It says use the points in the graph to make the table. So This is our x-axis down here. Right? This one's always our x-axis, and this one's always our y-axis. So just like our table, this is our x, and this is our y. So they looked at the weight on the Earth was at 6, and it was at 1 for the moon. So they put 6, 1. And then they got 12, 2, and this point's at 18, 3, and this point way out here is at 30 and 5. So that's what they listed. So that's how they made this table. Okay? So then we're gonna do our ratios and see if these all equal. Remember, we always do y over x's for our ratios. So we're gonna go 1 over 6, well, that's just 1/6, we're gonna leave it. If we do 2 over 12, that also reduces to 1/6, right? Divide by 2. And 3 over 18 also reduces to 1 over 6, divide by 3. And our last one, 5 over 30, and is also 1/6, divide by 5. So our k, or our constant, is 1 over 6. So our equation then would be y equals 1 over 6x. All right, so we have 15 bicycles are produced each hour at the Speedy Bike Works. Show the relationship between the number of bikes produced and the number of hours, the proportional relationship. Then write an equation for the relationship. So we have number of hours, so I'm gonna fill in some hours for you. So let's go 1, 2, 4, and 6. And then I want you to do is pause and see if you can figure out how many bikes were produced in each of those hours that I have listed for you. Now, before you do that, just realize you could have put any numbers in there. I could have put 1, 4, 8, and 10. I just put some random numbers in there. I did not purposely pick, those numbers. It was just random. So hopefully you paused and actually filled this in. So for 1, you should have gotten that it was 15 bikes, and that's because it said 15 bikes are produced at each hour, so it's 1 hour. So then at 2 hours, we would have gotten 30. At 4 hours, hopefully you got 60. And at 6 hours, hopefully you got 90. And all we're doing to get this is I took 1 times 15. Here I took 2 times 15. And 4 times 15. And 6 times 15. That's all I did to get these answers. So let's set up our ratios. Again, this is supposed to say y. This is a typo. I should say y right here. Fix that. It told us this is x and y, but actually it said x and x, so fix this one so it says y. Remember, our ratio is always y over x. So we would do 15 over 1, which is 15. And 30 over 2, 15. 60 over 4, I almost wrote 4 over 60. 15. And 90 over 6. 15. It's just the opposite of all these, right? Because these are division signs, too. So then our equation would be y equals 15x. All right, so it says the graph shows the relationship between the amount of time that a backpacker hikes, sorry, my screen was blocked, hikes and the distance traveled. So the first thing they actually asked us was, what does the 0.56 represent? Okay, so the 0.56 is right here. So this is your x, and this is your y, but this is a real world situation. We're hiking, right, in a certain amount of time in a distance. So why don't you see if you can figure out what does the 0.56 mean based off this situation. So there's a couple different ways you could have written it, but it just means that in 5 hours, can hike 6 miles. You also could have said you can hike 6 miles in 5 hours. Okay, so that's the other way you could have written it. What is the equation of the line represented? So to find that out, we have to find our constant. So remember, we have to set up ratios with these points. So our first point was 5, 6, so we would write 6 over 5, right? Remember, it's y over x. Y over x. So that's just 6 over 5. So let's check our next one. It's at 10, 12. So if I write 12 over 10, that does reduce to 6 over 5 by dividing by 2. So that's a good sign. And then our last one is 15, 18. All right, 15, 18. I'm going to write it right here. So 18 over 15. And we would divide this by 3 and get 6 over 5. So all of them came out the same, so we can then write the equation y equals 6 over 5x. All right, so main things to remember is that k equals our constant. The ratio is always y over x. I'd say those are the main things to remember. All right, so here's your independent practice. It's very similar to the problem we just did together. It says, what does the point 260 represent? And then it wants you to find your equation of your line. Make sure you set up those ratios like I did here for these 3 points here. All right, until next time.